All right, let's jump right into this explainer. Today we're going to completely change our perspective. I want you to imagine, just for the next few minutes, that you are a global factory builder. You're stepping into the incredibly complex, super high-stakes world of industrial geography. To actually succeed here, you need to understand the fundamental economics of manufacturing and exactly how raw materials are transformed into the modern world we see all around us. We're going to unpack this whole concept of secondary activities and basically give you the blueprint for how global industry actually works.
So here's our roadmap for today. First up, the power of manufacturing. Second, inside the modern factory. Third, where do industries locate? Fourth, classifying the industrial world. And finally, number 5, the rise of high tech.
Okay, kicking things off with part 1, the power of manufacturing and how we add value to nature.
To truly get a grip on the global economy, we have to start with a really fundamental question. What makes the raw resources of our planet actually useful to us? Well, all economic activities basically boil down to human survival, right? But secondary activities are kind of the game changer here. They're defined as the processes that actively add value to natural resources by transforming them. Whether we're talking about manufacturing, processing, or construction, this entire sector is all about taking something raw directly from nature, like from a farm, a forest, or a mine, and turning it into something highly functional and valuable for society.
And this contrast brilliantly illustrates that whole concept of value addition. Think about a raw cotton ball. In its natural state, it really has very limited use. But once you transform it into spun yarn, it becomes immensely more valuable because now it can be woven into clothing. The exact same thing goes for iron ore. Straight out of the ground, you certainly can't build a car with it, but convert it into steel, and suddenly it's incredibly valuable for making heavy machines and tools. Secondary activities are literally the bridge between raw nature and human progress.
Moving right along to Section 2, Inside the Modern Factory, where we talk about scaling up.
So we know what manufacturing is in theory, but let's look at the modern era. Humanity has largely moved away from the literal primitive meaning of manufacturing, which actually means to make by hand, and shifted toward these massive mechanized operations. Modern large-scale manufacturing shares a few undeniable traits. First up is specialization and mass production. Unlike traditional craft methods where an artisan makes a product to order, mass production has workers doing one specific task repeatedly to pump out standardized parts. Then you've got mechanization and its advanced cousin, automation, where machines literally use feedback loops to think without human intervention. Add in intense technological innovation plus massive complex bureaucracies to manage it all. But honestly, the most fascinating characteristic? Its uneven geographic distribution. Get this. Major concentrations of modern manufacturing cover less than 10% of the world's land area. Yet, these highly concentrated spots are the undisputed centers of global economic and political power.
Which brings us to Section 3. Where do industries locate? Basically, the ultimate profit puzzle. This is a massive part of our Factory Builder Guide, the why and where of global industrial geography. I mean, why does a giant steel mill open in one region, while an electronics plant pops up in another? The crucial point is this. Industries have one primary objective, and that is maximizing profits by reducing costs. Simple as that. So, they absolutely must locate at the exact geographic points where their overall production costs are at an absolute minimum. Finding that sweet spot, that minimum cost, is a huge balancing act involving 5 main factors. First, access to the market. You need people who actually want your goods, and more importantly, have the purchasing power to buy them. Next is proximity to raw materials. This is a big one. It's absolutely critical if your materials are perishable, like dairy, or if they're what we call weight-losing. For instance, a heavy steel plant needs to be right next to its raw materials because transporting bulky, heavy ore over long distances totally destroys your profit margins. Then, energy sources. The aluminum industry uses insane amounts of power, so it has to locate near massive energy sources like hydroelectric plants. After that, you've got to factor in a steady labor supply. And finally, transport and communication. Places like Western Europe and Eastern North America have highly developed transport networks, which historically triggered massive industrial concentration in those exact areas.
Now, there is a really cool exception to all those strict location rules. We call them footloose industries. These guys don't depend on specific, bulky, or weight-losing raw materials. Instead, they rely on component parts that you can get from pretty much anywhere. They usually produce goods in small quantities, have a smaller labor force, and are generally non-polluting. For them, the single most important location factor isn't being next to a coal mine or a giant local market, it's simply having access to a good road network.
All right, on to Section 4. classifying the industrial world. Let's organize the chaos. Now that we know where industries go and why, we need a system to prevent total cognitive overload when looking at the sheer variety of factories out there. As a factory builder, you can neatly classify any manufacturing operation based on 4 pillars: size, inputs, output, and ownership. Whether it's a small-scale agro-based food processor owned by a private investor or a gigantic, state-owned mineral-based steel plant, every single manufacturing entity on Earth fits right into this comprehensive system.
Let's zoom in on that size classification for a second, starting at the very foundation, the household or cottage industry. Think about artisans crafting pottery or weaving baskets. This is the smallest unit of manufacturing. It completely relies on family labor or part-time help, using local raw materials and simple, locally devised tools, functioning entirely outside the modern factory system.
And the things they produce? Well, on a massive global, multinational scale, sure, they might have low commercial significance, but locally, they are absolutely vital. They produce everyday goods, foodstuffs, mats, containers, basic tools that are totally essential for local bartering and consumption in village markets. Big capital and massive transportation networks just don't have much influence here.
Bumping over to inputs and outputs, we find even more clarity. Inputs basically tell us what a factory consumes, right? Agro-based industries process field crops. Mineral-based ones use metals like iron or non-metals like cement. And chemical-based industries use resources like petroleum. But outputs? Outputs tell us where the product goes next, and this is a really vital distinction. Basic industries, like iron and steel, produce materials that serve as raw materials for other factories. Their output isn't going straight to you and me. On the flip side, consumer goods industries, also called non-basic industries, produce the things we consume directly. Your bread, teas, soaps, televisions, you name it.
And finally, Section 5, the rise of high tech, stepping into the modern era.
So, let's step out of that traditional smoke-stacked landscape of physical manufacturing and look at the cutting edge of the global economy. The latest generation of manufacturing is high-tech, and it is completely driven by intense research and development to create advanced scientific and engineering products. When these high-tech industries concentrate into highly specialized, self-sustained hubs, geographers call them technopoles. Think of Silicon Valley near San Francisco, or the Silicon Forest near Seattle. They are perfect examples of these powerhouses, usually springing up around beautifully planned business parks.
And the physical contrast between these two eras, it's like night and day. Traditional large-scale manufacturing is all about massive assembly line structures, heavy machinery, and armies of blue-collar production workers. The high-tech landscape, though, looks totally different. It's defined by neat, low, dispersed office, plant, lab buildings. Instead of manual labor, the workforce is heavily skewed toward white-collar professionals and highly skilled specialists who are using robotics, computer-aided design, and intricate electronic controls. All right, we've covered the whole shebang: the power of value addition, the mechanics of the modern factory, the strict laws of industrial location, and the rise of the technopole. So, I'm going to leave you with a challenge. Look around the room you're in right now. Pick an object. Based on the geographic framework we just went through, was it made near its raw materials? Was it near a massive energy source? Or was it from a footloose industry? What global location factors determined exactly where the objects around you were manufactured? Keep questioning the built environment around you, and I promise you will never look at a factory the same way again.